So hi, and welcome to Picterra product webinar. So this webinar is part of our quarterly sessions where we take the opportunity to provide you some updates on the new features, new improvements, new capabilities that we make available in the platform, and also to give you a glimpse into what we're working on and what's coming next. My name is Monika Lepkowska, and I am a product marketing manager here at Picterra, and I'll moderate a bit of the logistics throughout today's session. We plan about 1 hour with the first part dedicated to a presentation and the last about 10-15 minutes where we would like to take the opportunity to answer some of your questions. So at any time during the presentation, please feel free to put your questions in our chat box. And with that, let me introduce our main speaker and presenter at today's session, Julian Rebetes, who is our Chief Technology Officer at Picterra, and who will introduce you to our latest released feature, Dataset Exploration report. And with that, hi, Julian.
Hi, Monika. Thanks for the introduction, and happy to be here today and walk you through what we've been working on for the last quarter, really. So let's look a bit at the agenda that we have planned for today. So first, I will do a quick Picterra overview for those of you that are not familiar with what we are doing at Picterra. And then we'll have a big chunk of the time spent on our new feature, which is Dataset Exploration. So we'll go into some example and see how this is useful in your machine learning workflow. We'll also spend a bit of time talking about integration with the S3 ecosystem. And then, as Monika has mentioned, we'll have a Q&A session at the end. So I think you can send any question on the chat, and then Monika will read the question at the end. So just to explain what we are doing at Picterra. So Picterra, we are building a web-based software as a service for geospatial machine learning. So it's a platform that you can use for any geospatial imagery project where you want to detect some object on imagery that can be taken from satellite, drone, or planes. As I said, it's web-based, so you can access it from anywhere. You can collaborate with colleagues. You can automatically train a machine learning model to detect any kind of object. And then you can deploy this model at scale in a very easy and intuitive way. To explain a bit where we are coming from, so the whole reason we started the platform really is because we looked at the typical life cycle of a machine learning project in the industry. And what we saw is that a lot of these projects, they take first a very long time. So it can go from 6 months to multiple years. And usually a lot of them fail actually and never make it to delivering business value. And one of the big reasons for this is that this project, they involve different job functions. So you have software engineers that need to collaborate with the data scientists to deploy the model to production. You have the data scientists that need to collaborate with the annotation team or the GIS team to label the data. And then you have some quality control, some model maintenance, and so on. And so you have different team and a lot of communication overhead and so on. And so usually what happens is typical machine learning project, I think it's above 90% of them in the industry, they get killed before even going into production, which is a bit of a shame and a lot of wasted time. So compared to the typical machine learning project lifecycle, what we bring with Picterra is we bring an all-in-one platform to do this machine learning project. And so this means instead of having different teams collaborate with different software and having a lot of communication overhead between them, you can do the whole project on Picterra through a single unified platform with a single unified user interface. And so you can do everything from data organization, data labeling, data curation, to training a model automatically based on your training data, then deploying the model in production. I mean, we don't even have a deploy step. It's a transparent thing. And then you can also do quality control, model maintenance, and visualization, and share the results with the rest of the business. So really, we try to be a big time saver for a geospatial machine learning project. And all of this is done either through our UI or also through our API. So if you're more of the software engineering kind, you can also automate a lot of things with our public API. Where we stand in the geospatial value chain is we really work with geospatial imagery. So typically we work with satellite imagery from the typical commercial provider, but also with drone imagery or with airplane imagery. It doesn't really matter to the platform as long as it's geospatial imagery. Obviously, we support optical imagery, but also different kind of data like infrared, also SAR, which is not really imagery, but you can represent it as an image, and digital surface model, and a lot of other things that you can find in the geospatial world. We also support different way of connecting to the imagery, from direct upload to connecting to a WMS server if you have this in your company. So we really try to be very flexible on what kind of imagery you can ingest into Picterra. And then there is the different features that we have on the platform. So on one hand, you can develop machine learning models that we call detector. And we have some automated parameter search that we do for you behind the scene. You can also do all the data management, permission, sharing data within your team. And then you can also visualize the result and share some interactive web reports to showcase the result of the machine learning project. Below all of this is our infrastructure. So we put a lot of emphasis on the automated GPU scaling. So you can easily train a model and then run it at country scale by just clicking on a button, and it's already transparent to you. But under the hood, we scale and start some GPU machines that are needed to support your workload. And obviously, we also have a strong focus on data confidentiality, making sure that your data stays private as it should be. And then finally, as I mentioned, we have either API integration, so you can integrate it into any workflow that you have currently, but you can also export all of the results into various GIS software, so ArcGIS, QGIS, FME, and a lot of others. So again, we try to be very, very wide on what we allow as data in, and also export to as many data formats as we can to be compatible with many tools. So that was a bit the summary of the platform and what we do at Picterra. Now I want to do a deep dive into one of the features we've been working on for the last few months and that we are releasing today. And we call this feature Dataset Exploration, and you will see why in a minute. And the general idea is that it's a visual way to gain some insights into your training data and into your imagery. So before diving in the feature, I think it's interesting to explain a bit why we thought that would be useful to users. And I think you can see that solving at least two challenges that we've seen users run into. So the first one is once you have trained a detector, and this is not specific to Picterra, but really it's any machine learning model. Once you have trained a detector, you iterated a few times and you reach some kind of accuracy, but you're not happy yet with the accuracy. It's not high enough. But you're a bit at a loss of, okay, what should I do to improve the accuracy further? And this is very typical in a lot of projects. At some point, you run a bit out of ideas and you don't know where to focus on the data set to improve the accuracy. So that's one challenge that Dataset Exploration is helping with, and we will show an example of this in a minute. The other challenge is when you have a detector and there is, for example, a lot of false positive, you can use Dataset Exploration to get a better understanding in what situation the model is having false positive and what type of background is triggering false positive, or what type of geographical area is triggering some false positive. So really, Dataset Exploration is a tool that you can use to get some insights into issues that you might run into with your detector. If you break it down a bit, there is a few things that it helps with. So first, you can use Dataset Exploration as a tool to assess the coverage of your training area. Typically, what you want is that you want your training area to cover the variety in your dataset. So for example, imagine you have a dataset with your object of interest, sometimes on grass background, sometimes on desert background. You want to cover both of these in your training set, because otherwise the model will not be robust. You can also use the tool, therefore, to identify some parts of the dataset that are not well represented in the training set, and that could lead to then issue when you run the model in production, because you're running it on the type of background or context that the model has never seen before. Then overall, it should improve the dataset quality. So that's really the whole reason behind this, is build better detector and make sure users are building the best detector they can. And finally, a last point that is very key actually is that it also allows you to make sure that the validation set, so the set of data that you're using to evaluate the accuracy of the detector, is also representative of the data. Because if it can, and it very often happens, that the validation set is actually, let's say, too easy, and therefore you have a very high score, but it's actually not representative of the score that you would get in production. So it's very important to make sure the validation set has a lot of variety and is kind of challenging. So you evaluate the model in a setting that is as close as possible to production. So The way that the dataset exploration tool works on the platform is what we call a report. So it's something you can access from within the platform, and it takes the shape of what you see here on the right-hand side. We'll dig a bit more into how you can use the different elements. I think it's interesting to mention under the hood, it's based on unsupervised learning. So it doesn't need any annotation or any label data, but it's really using your imagery and to cluster the imagery into different regions. And as I mentioned, it's really a way for the user to discover patterns and the diversity in their data set and ultimately build better detectors. If you go a bit more in the technical details, the way it's working is, let's say you have an image. So you see an image here on the left. The way it works is it's breaking down the image into small tiles. So this is the colored rectangles that you see here. And for now, ignore the color, but you can just see that it's broken down into a lot of small colored rectangles. And then what it's doing is it's clustering these rectangles into groups based on their visual similarity. And so typically what you would expect is, in a simple case, if you have imagery that is covering some forest area and some lake, for example, you would expect to have a cluster with the forested area and a cluster with the lake. And this divides the data set into different groups. And then what we have below is a visualization of the clustering. So it's a visualization of the group, the different groups you have in your data set. And then you can see as an overlay, the yellow dots and the blue dots are training areas and accuracy areas. So this is the way that you can assess whether your training set and validation set is covering the data set in a good way. The way to access it, so the dataset exploration tool from within the platform, is by creating a detector and adding images to it. And then you can go in the detector report menu that we have and click on the dataset exploration report submenu. And then it will open the dataset exploration report. You can run a new report as you add more images to your dataset. So I think after the general introduction and kind of the motivation for developing this feature, I want to go through two examples that should explain you a bit more how you can use the tool and give you some intuition on how to make the best out of this new feature. The first example, we'll look at an urban scene example. So imagine we are detecting stuff like, it could be buildings, solar panel on roof, rooftop elements like chimney or something like this, or even road markings and so on. So any kind of object that you would detect in an urban setting. I think what's interesting specifically with the urban setting is that there will be a lot of differences between cities and geographic regions. So like a city in France, it doesn't look the same as a city in the US and so on. So depending on where you are on the planet, building or even the street might look very, very different. And obviously, if you want to create a model that can handle this variety, you need to make sure that you're covering the variety properly in the training dataset. So if you look at the dataset exploration report that we have generated over this urban dataset, it's divided in two sections. So on the left-hand side, you have the clustering view. So this is where you can see the different grouping of the tiles from the images. And so if two rectangles here are close, it means they are visually similar. It doesn't mean they are geographically close, but it's really on the visual similarity. So for example, you might have the forest in one area, the city center in another group, and so on. And then on the right-hand side, you can see your training images. So this is a grid of all of the training images I have in this dataset. And you can look at the color to figure out what rectangle is assigned to which cluster. So each color is a different cluster, a different group if you want. And so you can see what group each image is composed of. Then what you can do on the left-hand side is you can add an overlay to show training area coverage over your dataset. And this is very interesting in this case because you can see that at the bottom here, the coverage is pretty good. So the yellow dots are mostly covering the small rectangles. So this is good. But you can see here at the top, we have a bit of an issue where there is much less coverage green on the green cluster. And actually, if you zoom in on the green cluster here, you can see that from the small rectangle tiles, that this is mostly covering what we call, let's say, European city center kind of scene. So this is very interesting because it means that you have in your training set, you don't have any training area that is covering European city center. And what this means is if you try to run this model, to train this model and run it in production on a European city, it will probably completely fail to detect anything in the European city center because it never saw that in training. So what you would typically do here in this kind of case, since you've identified that this type of region is not well covered, you would actually then look at the images and find a few images that have the green cluster in them, and then decide that you want to focus the annotation effort on these images and therefore improve the coverage of your training data. So to summarize a bit this first way to use the dataset exploration tool, the general idea is that you look at the clustering visualization and you find zones that are not really well covered by the training areas overlay. And then once you have identified these zones, so in this case, we identified the European city center at the top that was not well covered by training area, then you can decide based on the imagery visualization part which image you should annotate to get the most out of your detector and to improve its accuracy. Obviously, you will also want to add some accuracy areas over the region that you identify, because in this case, you would also like to evaluate the detector on European city center. So you can really see this as a data curation tool where you kind of guide the annotation effort to make it as efficient as possible and focus the effort on where it will impact the accuracy of your detector the most. Good, so that was an example on how to use dataset exploration as a data curation workflow. The second example is a bit more about false positive. So this is a forestry use case where you will see that we are trying to detect holes in which new trees are planted. So this was part of forestry reforestation project. And the case was to detect holes and monitor how the tree is growing after being replanted. So this is one of the imagery that is in the dataset. What happened is that they are mostly replanting in the bare soil areas. And I think it's interesting to notice that there is also some snow on this imagery, which isn't present in any other image in the dataset. And we'll come back to this in a moment. If you zoom in a bit, you see that what we are trying to detect are really the small holes here for the new trees to be planted into. This is what we are after with this detector. Zooming in a bit more, this is the kind of the holes that we are looking for. So now what's interesting here is that if you look at the detection from the detector that was trained, it's doing fairly well in this bare soil area here. I think it's big. It has a really high accuracy, like above 95% accuracy on this type of area. But it has a lot of false positive here in an area that has some snow and also some bushes. So let's look at what the dataset exploration report produces on this example case. So now I'm switching to the platform and I can look at my dataset exploration report. And so you can see here that I have, as I mentioned before, the two parts of the report. So on the right-hand side, I can see all of my images, and the one I was looking at more specifically is this one in the middle that I'm zooming in. And you can see here from the color of the small rectangles that the region where there is an issue with false positive is mostly the red cluster and the pink cluster. So now based on this, I can actually look here at my visualization of the clustering. Well, first I can have a bit of an overview of the different clusters I have, and I can see that that's interesting. This one is mostly covering holes on a bare soil background. And then if I move here, you can see that I'm moving more to vegetated areas, so like grassy area, let's say. And then here at the bottom, looks like bare soil, but it's a little bit less uniform than the one we had above. And this one is much more uniform and doesn't have a lot of features. So you can use this really to navigate into your dataset and kind of get a feeling for the different context or different background on which your object will appear. So now to go back to the false positive issue, I said it was mostly about the red and pink clusters. So let's look at these two clusters. So these two clusters are the one that I have here. So you can see the red is this one, and it contains a lot of snow, basically. So red seems to be mostly areas covered with snow. And then the pink is a bit below here, and you can see that it seems to be more like bushes or something like that, so some low density vegetation. So now if I toggle the training area coverage overlay, I can notice a few things. First, I noticed that I don't have a lot of training area covering this region of the dataset. I have one here, but it's a bit far from this. And then I have another one that's covering here, but it's not really covering the snowy region, let's say. And the same can be said for the pink cluster at the bottom. I don't have any training area here in this region. And so this must be the issue for the false positive. So typically the action you would take from here is you would go back to your data set and you would add some training area on the region that are covered by this cluster, so the red and pink clusters. And while you're doing this, you can also do the same for accuracy area, actually. So here you can really compare the coverage of the training area to the coverage of the accuracy area and kind of identify spots where there is no accuracy area. So for example, here you would also add some accuracy area probably here at the bottom. So you make sure that you don't have false positive in the type of region represented by this cluster. So now going back to the slides, we have actually done this. So based on the Dataset Exploration report, we've selected some region to add training area to in the red and pink clusters that I was mentioning. And then we did a before after comparison. And so this is a zoomed in view of the before after. So remember before we had a lot of false positive, the area covered by snow and low density vegetation. And then after an iteration and focusing on these two clusters, we were able to get rid of most of the false positive really. We still have a few here. So you could do another iteration to improve the accuracy even further. But that's really to show that it's really a good way to iterate on a detector and kind of decide what you want to do next. So to summarize a bit, this second example, so this one was more about tackling false positive or kind of getting an understanding of why you have false positive in your detector. Here, the workflow would be that you identify an area where you have a false positive problem, and then you can use the imagery visualization to see which cluster this is affecting. And then based on the clustering visualization, you can check if you have an issue where you don't have enough training area covering the cluster where you have false positive. And then the action that you would take based on this is adding additional training area to your training dataset to make sure you improve the detector. So we've seen two examples of the dataset exploration feature that we are releasing. I also want to say that this is, you can use this for more than this. So we are also looking forward to users kind of diving into this and giving us feedback and probably getting some ideas that we haven't had yet on how you can use this feature. So it's also something really a powerful tool and you can gain insights. And as you are using it over time, you will also build intuition about how you can use it in the most efficient way. So we've seen that you can use it to support dataset curation by pinpointing underrepresented areas in your dataset and focusing the annotation effort on this, and therefore being more efficient because annotation is pretty costly. And you can also use it afterwards to support some analysis of false positive or some failure mode of your detector. I think what's also interesting to mention here is that we are only really getting started with this. So the underlying technology, which is based on unsupervised learning, is really key and really innovative. And it's basically a building block on which we can build many features to come. So dataset exploration is the first feature we are releasing based on this technology, but we'll follow up with dataset recommendation, which will be a bit more an active learning approach to the training, and also production drift monitoring, which is the same idea, but applied to the production stage. And I want to explain a bit more here why this is relevant. So production drift monitoring, typically the idea would be that when you run your detector in production, you might run it on an image that is very different from the training images. For example, let's say you have never seen snow in the training, then you run the detector on an image with snow, and obviously it will fail to deliver good results. And there isn't really a good way to see this now, but with production drift monitoring, the platform would actually be able to tell you, hey, it looks like this image is very different from your training set. So you might want to double check if it's really a good idea to run the detector as is, or if you should improve the detector before running it. So it's really a way for the platform to kind of warn you that some images are too different or are not represented in your training set. And this is typically something you would see over, let's say, when you are using a detector in production for a long time. It's most likely the data acquisition methodology or the way you normalize the data will have changed compared to what you did when it was trained. And therefore, it's really key to be able to monitor this kind of drift. So that's an upcoming feature that we are working on and we'll release in the next few months. So yeah, I'm done with the dataset exploration part of this webinar. I also wanted to give a quick update on our S3 integration, because we know a lot of our customers are big users of the S3 ecosystem, and we've also been working on making sure that we integrate well with this software. We have an integration with ArcGIS Pro. So we have an ArcGIS Pro plugin that you can install in your ArcGIS Pro desktop software. And it allows you to use Picterra from within ArcGIS Pro. So if you're already a heavy ArcGIS user, it's basically a way to use the power of Picterra and our cloud and GPU infrastructure without having to leave ArcGIS Pro. So it's really a way to make it more efficient and faster for you to leverage Picterra in your projects. The way it works is on one hand, you will have data. So you might have GeoTIFF data, you might have your data stored on the WS server, you might have existing annotation in a shapefile or GeoJSON or something like that you can easily import in Picterra. So you can use Picterra to build a model, to iterate, to use some dataset exploration tools to really get a good model. And then once you've built the model, you can apply it on new images and run it at scale from ArcGIS Pro without leaving ArcGIS Pro. And I think it's also very interesting here because it means you can leverage our cloud infrastructure. So you can run a model on a huge quantity of image from within ArcGIS Pro without needing to buy an expensive GPU for your machine. So you can really scale from ArcGIS Pro by using Picterra under the hood. And then obviously, since you're in ArcGIS, you can export to the whole ArcGIS ecosystem and use the existing integration that you have. So I have a small walkthrough of the plugin to give you a sense of what it looks like. Once you have installed the plugin, you will get a Picterra menu in ArcGIS. And then from the Picterra menu, you get different tabs with the different Picterra features that you can use from within the plugin. So, I mean, the first thing is you need a Picterra API key that you can get from your Picterra account. So that's just the setup phase. And then you can access the rasters that you have on your Picterra account. You can upload new rasters to your Picterra account directly from ArcGIS. Also manage detection area. You can do the same with detectors. So you can access all of the detectors that you have trained in your account and detect on the rasters that you have selected. And then obviously monitor the running of the detector. And once the results are ready, you can get them in ArcGIS in the vector layer and use them as any other ArcGIS vector layer. So then you can also do all the GIS operation you want on the results that you got out of Picterra. Yeah, that's it for the presentation. So I went over the dataset exploration feature and then quick update on the ArcGIS integration. So now I will hand it over to Monica, who's been monitoring the questions and answer any questions you might have. Thanks.
Thank you, Julian, for running us through this quite complicated story, I'd say, but very useful tool and very practical. There are some questions that we received directly here through the chat and some other observations that we've got shared. So first one, what kind of accuracy improvement can you expect when you use the dataset exploration report?
Yeah, that's a really good question. It's also, I think it's good, and it's also really hard to answer in a, let's say, a generic way, because obviously it will depend on your data set, it will depend on your detector, it will depend on what's the starting accuracy of your detector. If you're already at 99% accuracy, you might not get a 10% improvement, obviously. What we've seen, though, is that, for example, in the 3 holes use case that we demonstrated, we saw a jump in between 10 and 15% in accuracy. So we see quite a massive jump where we are able to go from below 90% accuracy to 95% plus accuracy. So it depends on the case, but it can help quite a bit in some cases. I think it's also important to mention that it's not only, I mean, accuracy is one thing, but you want to make sure that you're measuring the good accuracy. And so you should also use the tool to make sure the accuracy area over which you're evaluating the detector are really representative of your data set, because then you can have more trust in the accuracy. And this is what you want at the end of the day, right? Like it's easy to get 99% by having a single accuracy area, but what you really want is that you want to make sure that the accuracy area are representative of the accuracy you would get in production. And so this is what you can use the tool for as well, by making sure the coverage of accuracy areas is good.
Thank you, Julian. So Another question, I mean, the dataset exploration tool, the examples that you showed, they've actually shown the detector that's been already run, right? The question is, can this tool, can this report be also helpful before you train the model? So before you annotate it, so how does that look like from, let's say, the starting point when you start building a model?
Yeah, so I mean, you can totally do that. I mean, since it's using unsupervised learning under the hood, it doesn't need any annotation. So you can just upload a number of images in the detector and then run the dataset exploration to get a visualization of your images. I mean, obviously, you still need to know what you're trying to detect, or I mean, what's your object of interest. But then it can help you figure out and guide the annotation process from the start. So I don't know, for example, you run the dataset exploration tool and you figure out that you have 10 very different group of areas. So I don't know, some snowy area, some stuff on the water and so on. And so then you can decide, okay, I'm going to split the workload in my annotation team to make sure that I cover all of the variety that I have in the dataset. So yeah, you can totally use it to guide you as a starting point on your detector.
And using the tool, does that actually consume the credits on the platform or not?
No, it doesn't. So yeah, here, I mean, our philosophy generally is that everything in training a detector doesn't consume credits, because like we want our users to get the best detectors they can. So it doesn't consume any credits, and credits are only consumed when you run the detector in production afterwards.
Next question is, can you generate actually the dataset exploration reports on the detector that's been already done? It's in the project, so something that that's been existing already for a bit.
Yes, sure, you can. Yeah, you can access the menu and generate a report whenever you want, regardless of whether the detector is already trained or not. So it's completely, and it won't change the training of your detector. Like, the two things are completely separate. If you have a good detector, don't be afraid to run the dataset exploration on it.
Mm-hmm. Do you know when the dataset exploration will be available for the WMS-based imagery?
Yeah, that's a good question. I cannot commit to a date, but we are working on it. I hope in the next few weeks. So it's coming. We are running into a few technical challenges, so that will solve. But yeah, it will come in the next few weeks. Let's say end of the year, I would say.
Another kind of a bit more future-looking question. So, can the platform suggest the areas to annotate?
Yeah. So that's the idea with remember, like I said, the core technology, so the unsupervised learning and the clustering technology that we are using, so we use it for dataset exploration, but we also want to expand it for dataset recommendation. And dataset recommendation would be exactly this. So instead of you having to manually kind of go through the visualization and figure out where you should annotate, you would have the platform automatically suggest you where you should annotate in your dataset. So that's also something we are working on, and it will come in the platform.
Great. There's another question. I read it as I see it, so without trying to interpret anything. So question is, I have a project with 22 areas with same tree sculptures. Can I make it one project and train detector for all areas? So the idea is to do training areas in all images.
Yeah. I think if the question is whether you can build a single detector on multiple images with multiple training area, then the answer is yes. Yeah. And actually on the platform, what you can also do is you can merge detectors together. So you can also start with separate detector and merge them into one big detector to explore different ways to organize your training data.
Yeah, the tool actually looks similar to land use classification. Is it limited to specific classes?
Yeah, that's a good point. It's actually, so I think it's actually completely different. I agree that on the surface it looks like land use, but under the hood it's completely different. So land use, typically what you have is I don't know, a set number of classes. So you will have forest, urban, water, roads, I mean, whatever you have in your land use. But here it's completely unsupervised. So it's not a fixed set of classes. And I mean, it will work. I don't know if you have a very specific project analyzing vegetation on water or something, it will work as well, and it will pick up different groups based on visual appearance. So it's completely different from land use, even though, yeah, the idea of coloring part of the image is a bit similar on the visualization side.
Mm-hmm. Thank you. And I have a question from Anna. Can it extract rectangular data? I have in mind extract rectangular graph from a cemetery with drone images.
Yeah, you can do I think we have had people do this on the platform, I feel. I might be wrong, but I think we've had people try this on the platform, and if I remember correctly, it worked pretty well. So yeah, that's definitely something that should work. It always depends if you can see the object yourself, but I assume in this case it should be fairly well defined. Yeah, what's a grave and what's not. So I would be pretty confident about this.
Great. I actually think that we kind of ran through most or all of the questions that have been submitted to the chat for the moment. So, I mean, we always invite you to anyway stay in touch with us, and if there is any more questions on the subject, there's some information that we have available on the website. And following actually this the session, you will receive via email the recording and the slides. And we're always open to engage with you if there's any other elements that you want to deep dive or try out. So please reach out to us. Otherwise, I think that we can wrap up for today and stay in touch with you also for the next session. So we definitely provide those webinar sessions. We run them quarterly to be able to provide you with the latest information about what we're working on and what we've released, and we're open for your feedback. So please, by all means, use any of the channels, communication channels available to reach out to us. And well, thank you, Julian.
Thanks, and thank you for attending and the many questions.
Thank you.